Right, yeah, welcome back again. We want to look at chi-square at this point, and I want to quickly explain that chi-square is not really a parametric test, so to say. It could be used for parametric and non-parametric. The reason is because chi-square does not actually depend on category on a numeric data. Okay, it depends on categorical data. So that is why it's not required for any assumptions because it's not based on numeric data. It's basically on categorical data in your data set. So you may want to test your categorical data in your data set. So chi-square comes in handy. So there are two categories of chi-square we want to look at, and this is the first one. So the second one will be the next class. All right. So and the first one is to look at chi-square for one categorical variable. So that is the first one. And it certainly means that they want to test whether there is a meaningful difference in the proportions of various categories. Okay, we have categorical data in your data set. You want to test if there is a meaningful, significant difference. Okay, in the proportion. Okay, meaningful, significant. First thing is significant. Okay, significant difference. Right. So let's put it this way so that I can be more clearer. Okay, good. So it's clearer now that whether there's a meaningful, significant difference in the proportion of the category. So we want to see if there's a difference. Of course, you may see a difference there, but you want to know if the difference you see is not by chance, it's significant. That's the purpose of the test. All right, so we're going to be using a data set called Titanic. This Titanic, where there are different categories of Titanic in R, so take note of that. But the one we are going to be using come from this Mosaic, Mosaic library. So you have to run if you have not installed, you can install the library and run it. So that's the one we are going to be using. So we run this and see what is inside. Let's glimpse it first and see how the data look like. Let's glimpse it, and if you are not seeing glimpsing coming out, it means you have not load tidyverse. Okay, that is why you are not seeing glimpse. Sometimes you want to use glimpse, you cannot see it coming out. So it's not working. It's because you did not load tidyverse. I have loaded it. I've used it several times, so that's why it's coming up. Okay, so take note of that. Titanic, let's load it. All right. Let's see what is inside. All right. So you can also, before you go there, you can also start to check here Titanic. Right. Let's see. All right. Good. You can see DG Mosaic. Let's see that the data set containing some demographics and survivor of people on board the Titanic, right? A data frame with 2,201 rows and 4 variables. So it's so many. Okay, we have a class factor variable containing the class of passengers. We have first class, second class, third class, or we have crew. So we have crew there. So you're able to understand the data very well so that you know what when you are working, you know what you are doing. We have gender, sex, male or female. This is this one. We have age group. All right, age group can be child or adult. Okay, this information is not very reliable because it was inferred from body document that did not state actual age in years. So we don't have age in years. That's why we have child or adult. Right? We have survived. Those do these persons survive or not or not? So that is yes or no. So this is basically the data set. You can see all of them you have here, they are both categorical variables. All of them. Both class, both sex, both age, both survive, they are categorical variables. You can see that very clearly. And it's very easy to work with under this particular section. So want to see first, want to let's you can use any particular variable among them, okay, at least meaningfully based on your research questions. Now we want to look at a class variable first. We create a table function here. We see the table passing our data set Titanic dollar class. Let us see first. Okay, how many? Let's see the proportion of each of the class group. In the first class, we have 325 passengers. Second class, we have 285. Third class, we have 706. And crew, we have 885. Right, that's so many. So that is the total number of people we have there on board. All right. So now we have seen that we have various proportion of this class. Okay, is there a statistically significant difference in the proportion of the class we have in the class group, this class group, right? Our threshold alpha is 0.05. So anything p-value we get that is less than 0.05 is significant. It means there is a significant difference in the proportion. If our alpha value is greater than 0.05, it means there's no significant difference. So we can even create a what we call hypothesis, okay? H0 and H1 alternative hypothesis, non-alternative. This particular test of proportion is called chi-square goodness of fit test. This particular one, okay? Take note. That is what it's called, all right? So we can say the proportion of the class are equal, which means there is no difference. That's what it means. There's no difference. Or we can say that, okay, the proportion of the class are not equal, which means there is a difference. That is very simple to understand, right? So let's create a variable, okay? Let's call it all class, okay? All class. And the same thing we have done here, let's do it again, okay? We just say table, Titanic class, we pass to all class. We have run it, so we have assigned that table now to all class. So the same thing we did just repeated here, okay? We assign to a variable now called all class. Okay, so now you can do chi-square in two ways, whether by piping or direct method. So direct method is very simple, right? Just chi-square dot test, you pass in all class here. It's called test for proportion or goodness of fit test. Okay? So when you run this line, you have this. Or you can also run it in form of a piping. Say Titanic, you select class, which we are doing here now. Select class, you pass your table, then chi-square. So we run this now to give you the same thing. Okay, you have the same thing, okay? So look at it. 2.216, DF3 and 467. That is 467, DF3, 2.2. So we have the same thing. But then the test we are seeing here is significant because this is less than 0.05. This is 0.0005 which per minute to 16. So it's highly significant. And what does that tell us? Tell us that because p-value is less than 0.05, to the proportion, if the proportion were equal, the probability of sample data providing a difference in magnitude or more is less than 0.05. Therefore, we get the null hypothesis H0 that the proportion are equal, which is evidence that the proportion are not equal. Alright? So we reject null hypothesis. We reject this null hypothesis that say the proportion are equal. I say there's no difference. Take the alternative of this particular alternative hypothesis, which say the proportion are not equal. So this is what we do reject this. Okay. So that is how we test for chi-square. Goodness of fit is basically on one categorical variable. That's all, nothing else. And it's very straightforward. So you must learn how to just do your table first, your table of frequency or proportions, and then you can now pass it to this chi-square. You need to run it. That's all. So I will see you in the next class when I will be going to the second part of it. Thank you so much for listening.